In this video, we're going to form and solve a quadratic equation using Pythagoras theorem. So we've got a right angle triangle here, and we've got the three side lengths in terms of x, and we want to find the value of x. Now, if we have three sides of the right angle triangle, we know they're related using Pythagoras theorem. And if you haven't seen my video on Pythagoras theorem, please watch that first. So remember, if we have the two shorter sides of A and B, and the longest side, the hypotenuse as it's called, is C, then Pythagoras theorem states that a squared plus b squared is equal to c squared. So let's substitute in those lengths in the diagram. A is x minus 3, so it's x minus 3 all squared, notice the use of brackets there, plus b squared, so x plus 1 squared, and that is equal to c squared, which is x plus 8 squared. So now I've got my equation, and now I just need to simplify it and solve that. So I've got these bracket expansions here. I could write the x minus 3 out twice and then just do each thing in the first bracket times each in the second. But I've got a quick way to square brackets if there's two terms in that bracket. So what you do is you do the first term squared, so x squared. Then you do the product of the two terms and double it. So x times minus 3 is minus 3x. Double it is minus 6x. And then you do the second term squared. So minus 3 squared is positive 9. And that's the quick way to square it. You can do the same for the next one. You do the first term squared, which is x squared. You do twice the product. So x times 1 doubled is 2x. And then you do the second term squared. So that's plus 1. And if you do the same on the right hand side, you get x squared plus 16x plus 64. Nice little trick that. Now let's tidy up by collecting like terms. I've got x squared plus another lot of x squared, which is 2 lots of x squared. I've got minus 6x plus 2x, which is minus 4x. And I've got this 9 plus 1, which is plus 10. And that's equal to x squared plus 16x plus 64. Now, to solve a quadratic equation, you want to get 0 on one side. I've got more x squared on the left than the right, so I want to get rid of that x squared. I'm going to do that by subtracting x squared from both sides. But because I want 0 on one side, I also want to get rid of that 16x and the 64 on the right-hand side. So I'm going to subtract 16x and subtract 64. So I'm going to do the same to the left-hand side. So now 2x squared minus x squared is x squared. Minus 4x minus 16x is minus 20x. And the 10 minus 64 is minus 54. And the right-hand side, it all cancels, giving 0. So now I've got a much simpler quadratic here. Now I've got to solve this quadratic equation. Now the question says, give your answer correct to 2 decimal places. And that's a hint that this quadratic equation here doesn't factorize, that we don't have nice values, because it talks about decimals. Now, if you have a quadratic equation where it's like 1x squared minus 20x minus 54, and it doesn't factorize, you've got to use the quadratic formula. And the quadratic formula is this. If you have ax squared plus bx plus c is equal to 0, then x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Now in this particular problem, the a is the 1, the b is minus 20, and the c is minus 54. So let's substitute those values into this equation. So we've got x is equal to minus b, so minus 20, which is positive 20, plus or minus the square root of b squared, so minus 20 squared, which is 400, positive 400, minus 4 times a, which is 1, times by c, which is minus 54. And that's all over 2a, so all over 2 times 1, which is 2. Now, let's put that into our calculator. If I do it with the positive case first, because the plus or minus here means you can either add or subtract to get 2 different solutions. So if I do it with plus first, so my calculator gives me 22.41, it says 2 decimal places. And if I do it with the negative instead, so where I've got the plus or minus, if I do it with minus instead, my calculator gives me minus 2.41 to 2 decimal places. Now, we want the value of x. But the thing is, it can't be the negative solution. X can't be minus 2.41, because otherwise this side length here would be minus 2.41 plus 1, which would be a negative side length. So what we do is we put a cross through that to reject that solution. So x is just the 22.41. So I'm going to put that as the answer, 22.41, and that is the final answer.